All right, this is example 4, estimating a population mean. An insurance company wants to estimate the mean life expectancy for an American male. American male, big population, millions of men. All right, we want to estimate what that would be. How long would the average American male live, the whole population? So, it also goes on to say that they want us to find a confidence interval. So putting those two ideas together, and yes, there's a lot of reading comprehension going on here, but if we want to find a confidence interval for a mean, the very first question is standard deviation. Start at the top, answer the questions, and navigate your way down. All right? So I'm a flowchart guy. Start there at the top. The very first question has to do with standard deviation and whether it represents all American men or just a small sample of men. Is the standard deviation from a population or a sample? Population, sample. Well, here's some reading comprehension going on here. Let's skim the question and look for the two words, standard deviation, and circle them, shall we? I can't circle them up here. I wish I could, but there they are, standard deviation. Okay, so I'm reading backwards until I find the beginning of that sentence that contains those two words. And it starts right there with the word when. And let's start reading together. When the death certificates of 84 randomly selected American men are chosen, the mean was 76.2 and the standard deviation was 9.4. I hope you would agree with me that that standard deviation in that sentence would be for those 84 randomly selected men. And that's a sample. So in this case, that standard deviation, since it's for those 84 American men, is a sample. So the question of standard deviation, sample in this case, 84 men, standard deviation, sample. All right. Now we need to read the question to see if it says anything about being normally distributed. And if it does, then this will be our formula. But let's read the question first to see if it says anything about being normally distributed. Look for the two words, normally distributed. All right? So let's read together. Looking for the words, normally distributed. I don't see the words normally distributed. No. They did not tell us that that population is normally distributed. No. Now look, if they sampled fewer than 30, we're down here to this, we don't know how to do the problem. We'll write that phrase like we talked earlier, and that could be the case. But I believe it said that they sampled 84 men, and 84 is indeed more than 30, and that puts us right here, and that would be the appropriate formula for this. They sampled 84 men, and that's more than 30. I want to take you back to the central limit theorem, you might recall, where that threshold was 30. So that's kind of a big deal in statistics, is sampling at least 30. All right? But yeah, they sampled 84 men, that's more than 30. Now if they had sampled fewer than 30, then we're down to the more advanced techniques that you would learn later in your life, when you take more statistics next year at Princeton. Oh, I'm sorry, Harvard. Oh, Yale. Oh, Stanford. Okay, I'm sorry. But anyway, when you take future stats classes, you'll learn those other techniques. Anyway, let's put in the things that I hope we're familiar with. We hopefully know that the symbol X bar represents the mean of a sample, and that would be the 76.2 year average lifespan for those 84 men. That would be the X bar for this question, 76.2. Let's skip this information for now. That's going to be new here. S is the symbol we use for the standard deviation of a sample. That would be that 9.4 years of standard deviation for the 84 men. And the N would be the fact that they sampled 84 men. Sample size, as it's always been. All right, now, T, that's different. We're here now to introduce you to a new table All right, and so if you will go to the slide labeled Students T-Table, there's a story behind why it's called that and everything, which is kind of interesting, and you can read about William Seeley Gossett in your materials. He's a gentleman who worked at Guinness Brewery and all this, and if you want to read about it, it explains why it's called the Students T-Table. But anyway, if you look here at the bottom, the T curve, the T distribution, is symmetrical, much like the standard normal. Now, I'm exaggerating the picture here, and I do this for my own purposes, but people will tell you that with a T distribution, generally the data is a little more dense towards the middle, all right? So what I do, and I know the picture at the bottom doesn't look like this, but when I'm drawing a T, I kind of exaggerate the fact that it's a little more of a peak in the middle here. And much like the Z, it's got a 0 in the middle, okay? But you read it in a very, very, very different way. So first of all, if we go back and read the question, it says that they want to use a 95% confidence. So I'm going to write that down. 95% confidence interval. We don't have to cut it in half this time. This table is actually easier to read. The other thing that you'll notice here is DF, and that's an acronym, an abbreviation, whatever the word would be, for degrees of freedom. So these two things taken together are what we're going to do when we go back and read this different table here. And n minus 1 would be your sample size minus 1. So that would be the 84 men that were sampled minus 1, 83. So we're going to look for a 95% confidence with 83 degrees of freedom. So now let's go back to the table and discuss how you would do that. You will notice at the top here of this Students T-Table, it says confidence intervals, which is what we're doing. And there's a 95% there. It would be this fourth one over, pardon me, right? Confidence intervals, 50, 80, 90, 95. We're in that column that says 95, all right? And then the degrees of freedom start at 1 and work their way up to 28, and then there's an infinity symbol at the bottom. What that is saying is any value for degrees of freedom beyond 28 would be the bottom line of that table. So, once you exceed 28 degrees of freedom, you're going to go to that last line. So since we have 83 degrees of freedom, we're talking about the last line here. So if you look at the intersection of that, 83 degrees of freedom and 95% confidence, I hope you see on the table that you've printed out 1.960. And that gives us that multiplier there. So yes, it's a different table. It's actually easier to read. Difficult for you to read, I imagine, on the video, but pull out the printed version of it and hopefully it'll all come together. So once we get the right formula and pull that number from the table, and by the way, there would be a negative 1.960 down here and a positive up here. Okay, but basically, when you do the T-table, level of confidence, degrees of freedom. Those are the two things that lead you to your T-score. And then it's mechanical arithmetic after this. You have 76.2 plus or minus, and then all that right there would be the margin of error. I'll go ahead and multiply that out and see what I get, and hopefully you'll get the same thing. And, you know, the button pushing is obviously hard to do from a distance here, but you know, snob up here, that's the order of operations right there. And so then, once again, in order to create so we're basically saying, I think the average American man would live somewhere around 76.2 years, give or take about 2 years, right, give or take. That's what makes it an interval. And once again, you get the smaller number, the low end of your estimate, by subtracting the 2.01, and you'll get the upper end from doing addition. And look, you have the answers in front of you, so why don't we just put it up on the screen here? But the slide that follows example 4 would have the final answer to this, and the fact that the 95% confidence interval, let's make sure to put the level of confidence, and this is just the arithmetic there, 74.19 to 78.21. And if we do this process a large number of times, 95% of the time following this process, the actual mean for the whole population will fall in that interval. So, there you go with that. That was example 4. We've covered, I believe, every scenario, and now we'll probably just bounce around and do a variety of different questions here. So, hoping it makes sense. All right, good job, you guys.